My name is Robert Healy. I'm a postdoctoral researcher here at the Centre for Research into Atmospheric Chemistry. Specifically, we look at the chemical reactions that are important in the atmosphere, and in our case particularly the lower atmosphere, that's called the troposphere. We try to mimic the chemical reactions that happen in ambient air, and to do this we use this simulation chamber, which is essentially a large Teflon vessel where we can control ambient conditions like temperature and relative humidity. We also use a bank of UV and visible lamps which represent the solar irradiation. And into the sealed vessel then we can introduce particular pollutants that we're interested in. So specifically we want to monitor how long these pollutants will last, how long they'll survive in the atmosphere once they're emitted. And also we can look at the chemical products or the particles that these species form once they're released. So there's man-made or anthropogenic emissions. Typically you have industrial processes, or you might have vehicular exhaust emissions, shipping emissions, but also there's natural input. So this is gas-phase species that are released by trees and forests. And they can also be important from a climate point of view, because some of the species can absorb solar radiation or reflect solar radiation, so they can have different impacts on the Earth's radiation budget. These emissions are of particular concern because vehicular traffic and shipping traffic in particular, these activities produce a lot of particles or particulate matter, which can be specifically harmful to lung tissue when it's inhaled. So the particles are very fine. They're carbonaceous particles in the order of nanometers, a few hundred nanometers, which is extremely small. And because of their very small size, they're very mobile, so they can persist in the air, but more importantly, they can be breathed very deeply into the lungs. So very large natural material that you might breathe in, like sea salt or dust, these things are removed in the nasal cavity, and they typically don't penetrate the lungs very deeply, whereas these very small particles that we're interested in studying have the capacity to travel very far into the lung, and therefore they can act directly on lung tissue. So my research is specifically focused on identifying the different sources of particles or particulate matter in ambient environments like Cork Harbour, and we try to estimate the relative impact or importance of all of the different sources, whether they're man-made or natural sources of particulate matter. So we want to estimate how much of the pollution comes from vehicle exhaust, how much comes from industry, how much comes from shipping exhaust, for example, which is a new area for us, and also how much comes from domestic combustion, which is still a source of poor air quality in Cork Harbour. So this is the burning of smokeless coal and peat and wood in people's homes. And in the winter months in particular, we can observe very high levels of particulate matter, which of course is of concern for people who live there and are breathing this in every day. So we want to identify the different sources and estimate their relative impact.